Find the derivative of y equals f of x times g of x from first principles. So first we let p of x equal f of x times g of x. Now if y equals p of x, then dy by dx equals the limit as h tends to 0 of p of x plus h minus p of x over h. And we recall also that f dashed of x equals the limit as h tends to 0 of f of x plus h minus f of x over h, and similarly for g dashed of x. Now we have that p of x equals f of x times g of x, so p of x plus h equals f of x plus h times g of x plus h. We take the definition of dy by dx and we make the following substitutions to obtain the limit as h tends to 0 of f of x plus h times g of x plus h minus f of x times g of x all over h. And now to proceed, we have to expand this expression in terms of f dashed of x and g dashed of x. Now we note that both terms in the numerator involve products, and to help us expand these expressions we are going to use some geometrical intuition. So if we consider the product 3 times 5 and we draw a rectangle whose sides are 3 and 5, then we note that the area of this rectangle, the region shaded green, is 3 times 5. And more generally, for the product a times b, if we draw a rectangle whose sides are a and b, then the area of this rectangle is a times b. So if we now take a rectangle whose sides are f of x and g of x, then the area, the region shaded green, is f of x times g of x. And if we now allow x to increase to x plus h, and we construct a rectangle in the same way, then we obtain a rectangle with sides f of x plus h and g of x plus h. Now recall that we are interested in the numerator of this expression, and we note that we have f of x plus h times g of x plus h minus f of x times g of x, which we can now interpret as the difference of these two areas. So if we superimpose the left rectangle on the right rectangle, then we see that the numerator is the difference of these two areas, which is the area shaded white. Now to describe this area algebraically, it's useful to chop it up into 3 chunks, as indicated by the dotted lines. And we can now label the various dimensions as follows: f of x plus h minus f of x, g of x plus h minus g of x, and we will find it useful to label g of x plus h minus g of x as delta g, where delta means the change in. So delta g means the change in g. And we should note at this point that the quantities f of x plus h minus f of x and g of x plus h minus g of x are useful because they appear in the numerators of the expressions for f dashed of x and g dashed of x. And now we can represent the numerator as the sum of these 3 areas as follows. It is the area of this blue region, which is f of x times g of x plus h minus g of x, plus the area of this region, which is f of x plus h minus f of x all times g of x, to which we finally add the area of this region, which is f of x plus h minus f of x all times delta g. And so with that expansion, the expression for dy by dx turns into this complex expression whose numerator is the sum of 3 separate terms. And now we proceed algebraically. We split the complex numerator into 3 separate fractions, each with denominator h, and we turn the limit of a sum into the sum of limits, And on noting that neither f of x nor g of x depend on h, we pull them out from the limit, as seen in the first two terms of this sum. And now we note that the limit as h tends to 0 of g of x plus h minus g of x over h is in fact g dashed of x. And similarly, we note that the limit as h tends to 0 of f of x plus h minus f of x over h is f dashed of x. And so our expression reduces to f of x times g dashed of x plus f dashed of x times g of x plus f dashed of x times the limit as h tends to 0 of delta g. Now we recall that delta g equals g of x plus h minus g of x, and this must tend to 0 as h tends to 0, since x plus h tends to x as h tends to 0. And so consequently the value of g of x plus h tends to the value of g of x as h tends to 0. So the limit as h tends to 0 of delta g is 0, which removes the final term, since 0 times f dashed of x is 0, and thus we have that dy by dx equals f of x times g dashed of x plus f dashed of x times g of x. And so we see that if y equals f of x times g of x, then dy by dx equals f of x times g dashed of x plus f dashed of x times g of x.